Okay, so we're going to be speaking about ions. Now, I'm just going to make up an atom that I'm going to call atom J, and I'm going to say that atom J has an atomic number of 5. Now, this atomic number represents the number of protons, and protons are positively charged. Easy to remember, P for proton and P for positive. Now, if J is just a regular atom, then it will also have 5 electrons, as the number of electrons and protons in a regular atom is the same. And electrons have the opposite charge to protons, they have a negative charge. So if I was to draw what J looked like, I would draw a nucleus containing 5 protons. There would also be some neutrons in this nucleus, but I'm not going to show them, just to keep things simple. And then my electrons would be held in the shells outside the nucleus, and I would have 5 of them. First shell can only hold a maximum of 2 electrons, so I would have 3 electrons in my outer shell. Okay, so what can end up happening is during a chemical reaction, electrons can either be lost or gained. So let's imagine then that during a chemical reaction I lost 2 of these electrons. So if I lost 2 of these electrons, my electron number has now changed to 1, 2, 3. I have 3 now negative, what we call subatomic particles, meaning either protons, neutrons, or electrons. So I have 3 electrons which are negatively charged and 5 protons which are positively charged. So the way I'm going to write this is I'm going to write J with a 2 plus to show that this has 2 more protons than it has electrons. So let's have a look at another situation. Let's say, for example, this time, going back to the beginning again, this time this atom gained, let's go with this time this atom gained 2 electrons. So it gained another electron here and maybe another electron here. So now it has 7 electrons and 5 protons. So it has 2 more electrons, so 2 more of the negative subatomic particle than the positive protons. So this is now going to be represented as the letter J, 2 minus. Okay, so let's have a think then. You can try one by yourself. Let's imagine this then gained another electron here. Could you pause the video just on a sheet of paper and just write down what you think the symbol would be here? Okay, so hopefully you've done that, and we are counting the number of electrons we have. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 electrons and 5 protons, and that means we have 3 more of the negative parts than the positive parts, so we're going to write J3 minus. Okay, so what can then start happening is we could have a situation where we might need to represent this in an equation. So let's say, for example, I had J here, and this J ended up gaining 3 electrons, which I'm writing as 3e minus. Then what is going to end up happening to J? Well, if we gain 3e minus, I'm therefore going to take this to 8, which means that J is then going to be represented by 3 minus. Now this could happen in another situation. You may have, say, for example, J, which then loses electrons. Now, when J loses electrons, what we tend to do is we tend to represent this like so. So let's draw out J with its full amount of electrons, which was 5. And if it loses electrons, it's then going to say turn into, let's go, it loses 2 electrons. It's then going to now just have 2 electrons that it is lost. So those 2 electrons are now not a part of this atom. They are separate to this atom. They are somewhere else. So the way we write this is we write it as J 2 plus, because we have lost 2 electrons. So therefore now, looking at this situation here, we have 2 more protons than electrons. And then we write down what we have in addition to this atom that is no longer a part of it, with 2 electrons now somewhere else but not a part of this atom, or ion even. Okay, so what we can then have a think about is, let's say for example I did J, which then went to, let's go with J4 plus. Could you write down what should go in this part here if you pause the video? Okay, so hopefully you've written that I have lost 4 electrons. So those 4 electrons are now no longer a part of that ion. They are now separate to them in addition somewhere else. So therefore we're going to write down plus 4e minus. Okay, so then what we can do is we can have a situation then where I might have something else. But I'm going to draw a little number line here to show how this works. So 0 would mean that there's no difference between the number of electrons and the number of protons. Plus 1, or I should probably put 1 plus, 2 plus, 3 plus, 4 plus. And going down this way, I'm going to do something similar. I'm going to write 1 minus, 2 minus, 3 minus, 4 minus. Okay, so if I'm getting more negative, so if I'm going down in this direction, excuse me, then what is happening is I am gaining electrons. So if I'm going in this direction here, I must be gaining electrons in order to get more negative. Whereas if I'm going in this direction here, I must therefore be losing electrons. Okay, so let's have a little bit of a think then. If, say for example, I had J, and we're going to go with 2 plus, and I added, let's say, 1 electron, what is going to be the outcome of this? Well, what I'm saying there is I'm starting with J 2 plus, and if I add 1 electron, I'm going to skip down 1 step to J1 plus. So therefore, the outcome of this is just going to be J1 plus, or I could just write J plus. Okay, let's have a look at another one. Let's say, for example, I had J, let's go with 3 plus, and I added 3 electrons. What's going to be the outcome? Well, J3 plus, and I'm adding 3 electrons, so I'm going down 3 steps, and that's going to go to 0, meaning no difference between the number of protons and neutrons, so therefore I'm just going to write J. Okay, so then we could think about doing this in the other direction. Let's say, for example, I had J 2 minus, and I then ended up going J, unknown symbol for my ion, but I lost, and remember what you lost goes into the addition sign at the end. I lost, let's go with 4 electrons. What is going to go in here? So I start at J2 minus, and I've lost 4 electrons. I know it's confusing that there's a plus sign there, but we've been through the idea of that is now not a part of that ion, but in addition to somewhere else. So I'm going to travel 4 steps. 1, 2, 3, 4. So therefore, I'm now going to be J2 plus. Okay, so let's see if you can try this one on your own. Let's go with 2 questions. Question 1, J 3 plus, and we're going to go plus 5 electrons. What is going to be the outcome? And then the second question is going to be J 4 minus, and I go and I lose 7 electrons. Very unlikely, but we're going with this. So pause the video and see if you can have a go at answering these two. Okay, so hopefully you've had a go at that. So J3 plus, and I'm gaining electrons. So I'm going to go in this direction. 1, 2, 3, 4, 5. So I'm going to then have J2 minus. And then if I am going with J4 minus and I lose 7 electrons, so I was starting here and I'm losing 7 electrons, then I'm being 1, 2, 3, 4, 5, 6, 7. So therefore I am going to be J3 plus. Okay,